Greetings to doctor. My name is Pravindra, son of Kannan, and my matrix ID is CE210-202. So today I want to explain the circuit I have made. For the circuit I have made is this one, figure 8.5. To find out the input voltage and technometer voltage for the motor speed. So this is circuit I have made. So just change the inside one with the value they given in the lab sheet in table 8.1.
So this is the circuit I have made. So just replace the value with like I told before, replace with the value in the table they given. So just after all set, run. And before that, make sure the input speed is correct. So the starting value is 400 RPM. So after you make sure, just click run and double click the input voltage to see the voltage of input. So for the better view, you just zoom it, click here and zoom it to view the voltage, and clearly see the voltage is 26 volt for 400 RPM. And for the technometer output, as the same, double click the technometer output and we can see the waveform here. So for the better view, you can move the graph actually. Just click this, move the graph and we zoom for view the better value. Zoom. Yeah, then we can see I zoom it for you. So we can see the value is 25.96 watt. Sorry, volt. And same go to the speed output. For make sure the RPM is correct at the end. So as like I told you, just move the graph. See 400 speed. So that's all.
So this is the table I filled from using the Simulink and getting the voltage. So from this finding, I can relate and conclude while the motor speed RPM is increased, the input voltage also increase. We can see that clearly the input voltage also increase. But when we go to the technometer voltage, while the input voltage is increased, the voltage for the technometer is slightly decreased in point form. We can see here is 26 volt and here is 25.96, and same goes here. The technometer voltage is slightly decreased and reduced. So the conclusion is while the motor speed RPM increase, the input voltage also increase, and while the input voltage increase, the technometer voltage is slightly decreased. And that's all from me. Thank you.
Today I'm going to explain about activity 2. So we're going to set the motor speed to 2500 and then the input voltage is 162 voltage. Next, we set the brake scale is 0. So for the 0, the motor speed is 2500 RPM. And then we're going to set the brake scale to 3. So the motor speed is for 3 is 2250. And then we set the brake scale to 6. For the 6 is the motor speed is 2200. Moreover, we're going to set the brake scale to 9. For the 9, the motor speed for 9 is 1800. and then we set for the brake scale to 12. For the 12, the motor speed is 1600. Next, we're going to set the value for brake scale is 15. For the 15, the motor speed is 1350 rpm, and then we're going to set the brake scale 18. For the 18, the motor speed is 1100, and then lastly, finally, we're going to set the brake scale to 21. The motor speed is 850. That's all from me. Thank you.
Assalamualaikum and very good morning. My name is Muhammad Anis Mustaqim bin Muhammad Shuaibi, and my metric number is CE210188. Okay, today I will present about activity 3, closed loop speed control system. Okay, this is the circuit that we need to build in order to simulate. Okay, in the circuit we have input voltage, proportional gain, electrical parts, mechanical parts, brake, torque constant, tachometer constants, and speed output. Okay, I will run the circuit when the brake is at 0. Okay, and press this, and the output will come. Okay, here are the wave. Let's see, we get 3.674 rpm. Okay, for the next brake is 3, so we just change here 3, apply, okay, and run. Okay, see, you can see the value is changed. The value is actually dropped 3.464. see here, from 3674 to 464. Okay, so the next step is same, which is we just change the value. For example, we change to 18, which is in here 18. We are supposed to get 2309. Okay, so when we run it, as you can see here, 2309, which we are getting, the speed is actually decreased. So what you can see here is when the value of brake is increased, the speed of the motor is decreased. Okay, so in the questions, so this is the motor speed rpm versus brake scale, which you can see here, the speed is decreasing at every brake that we set. For example, 0, 3, 6, 9, 12, 15, 18, and 21. Okay, for the next question, we have the brake scale at 80, the percentage regulation. So we did a calculation, which is the speed at brake 18 and the speed at no load, no brake. So we just take the 3674 and minus with 2309 and divide by 3674 and just multiply by 100%, and we get 37.15%, which is, for the comparison to activity 2, we got 56%, and for activity 3 is 37.50%. So this explains it that the circuit in activity activity 3 is actually better than activity 2, which is the percentage regulation is lower than the on the activity 2, because the drop in speed is called the drop. An ideal speed control system will process zero drop. So the ideal motor is supposed to be zero drop, which is in this case motor in activity 2 is higher than activity 3. So circuit for activity 3 is better than circuit in activity 2. So that's all from me. Thank you.